Hey guys, today's video is about model evaluation. We've discussed accuracy, error rate, class imbalance problem, sensitivity, specificity, recall, and precision in the previous videos. Wow, that's a lot. Today we are going to finish this section by learning F1 score. Before diving into F1 score, let's review some important concepts. Confusion matrix is a tool used to analyze the performance of a binary classifier, and we typically denote each position by TP, FP, FN, TN. Then, recall is the percentage of positive data correctly classified as positive, and is a measure of completeness. The formula for recall is TP divided by P. P here is the actual positive data, which is TP plus FN. Then, precision is the percentage of data classified as positive that are actually positive, and is a measure of exactness. The formula is TP divided by TP plus FP. The difference is in denominator. We now look at the predicted positive data, not the actual positive data. It's important for you to understand these concepts because they are the foundation of F1 score. Alright, F1 score is also called F score. It's the harmonic mean of precision and recall, and it's popular because it provides a single measure to evaluate the performance of the model. You might think it's just fine to look at both precision and recall, but a single number is particularly useful in some cases, such as grid search. To illustrate, this imaginary algorithm has three adjustable parameters. We call them x, y, and z. Each of these parameters has multiple possible values. To make the situation simple, we suppose each parameter has 10 possible values. But in the real world, some parameters can have hundreds or thousands of potential values. Therefore, this algorithm can generate 1,000 different models by taking combination of the parameters. To select the best model out of them, we need to do the grid search. And intuitively, it's much easier to compare just one number than two numbers when you have a huge number of models. Next, when we evaluate the performance of model, we want to maximize F1 score. It's because recall is a measure of completeness, precision is a measure of exactness, and F1 score is the harmonic mean of recall and precision. We would like a model to be more complete and more exact, so we want F1 score to be higher. To calculate the F1 score, the formula is 2 times precision times recall divided by precision plus recall. One thing to note is that F1 score is harmonic mean, so precision and recall are equally important in this measure. However, in some cases, we care about precision more or recall more, and we'll talk about this later. Let's look at an example. The model is used to predict the result of a medical test, and the accuracy is 0.936. The recall is 1/3. The precision is 2/5. We want to find the F score for this model. The formula is based on recall and precision, and we already calculated them in the previous video, so we just plug in the numbers. Therefore, the F1 score is 2 times 2/5 times 1/3 divided by 2/5 plus 1/3, which is 0.364. In fact, this number is much lower than accuracy, which is 0.936. As we talked about, accuracy doesn't work well in imbalanced dataset, and we now find F score can handle this problem better. Last, we need to know the pros and cons of a measure before using it. The first advantage of F1 score is that it works better than accuracy in imbalanced datasets, as we just proved in the example. Second, F1 score offers a single number for optimization, which is exceptionally useful in some situations, such as grid search. Then, F1 score penalizes model with many false negatives because recall is involved in the formula. It's important because sometimes false negative matters a lot. For example, in a cancer diagnosis, we absolutely don't want to predict people with cancer as healthy, and F1 score can reflect this issue properly. So, That's the main advantage of F1 score. Let's look at the disadvantages. The first problem of F1 score is the low interpretability. F1 score is composed of recall and precision, so it's really hard to say what exactly F1 score means. By contrast, accuracy is much more interpretable because it's just the percentage of data that are correctly classified. Therefore, you have to think about your target audience. They might not be able to realize what F1 score means. The second thing is recall and precision are of equal importance. This is a problem because sometimes we care about one measure more. For example, for random advertisements, we care more about precision because we want to know the percentage of potential customers that become actual customers. However, for access control system, we care about recall more because we want to know the percentage of people with permission that can actually get into the system. So sometimes we do want to emphasize one measure, but F1 score is limited. In fact, there is a general version of F1 score that can solve this issue, which is called F-beta score. I know I said this is the last video for the first section, but I really want to make another short video to introduce F-beta score because it's also important. Let's stop here for today. Thank you for watching my video and see you soon.